Hello everybody. This is going to be your limits test review. I'm going to go through and hopefully show you how to do all of these since I'm not here today. This is a fair representation of the number of questions that will be on the test and what you'll be asked to do. It won't be the same, but it'll be very similar. Now for number 1, this is going to be limit of a constant. So, if we take the limit of a constant, which is square root of 3, our answer is just a constant, which is the square root of 3. That's the nice one. That's the first limit property that we learned. The second one, since there's no problems going on here, let me focus, see if I could get a little bit better. Alright, didn't do a whole lot. Let me zoom in a little bit more so it's a little bit bigger. There it is. Since there are no problems as far as discontinuities or anything like that, we could do direct substitution. So direct substitution, which I'll abbreviate DS from now on. So it's 7 times negative 5 minus 2, which would be negative 5 minus, negative 35 minus 2, which is negative 37. Number 3, limit as x approaches negative 8. Another direct substitution because we have a polynomial. We just need to do direct substitution. So this is going to be equal to 7 times negative 8 quantity squared minus 2 times negative 8 minus 2. So by using our calculators here at this point, or if you don't have calculators, we will get one more step. I didn't do that right. 8 squared times 7, 448, plus 16 minus 2, 462. Big number, but that's a good number. Not a big deal for us. Now our next one. Is there any issue with plugging in 1/2? I see no. And since we have 2 that are multiplied together, we could just do direct substitution again. We'll get 6 times 1/2 times 1/2 minus 3 over 4. So this is going to be equal to 3 times, add these up really quick, 1 times 4 is 3, 2 times 3 is 6, so it's 4 minus 6 over 8, which would be 3 times quantity negative 2 over 8, so that would be negative 1/4, so this is negative 3/4. Now, our next one here. We have a vertical asymptote at 19. Our limit will not exist in this case. If we come in from the left and from the right, from the left we'll get a negative value, from the right we'll get a positive value, so we can't get it to infinity, so we're out of luck in that case. Alright, 1 does not make the denominator 0. It's a rational function here, so rational functions just get direct substitution. So this would be 2 minus 7 over 4 plus 5, which is negative 5 over 9. And that's our answer for number 6. If you run into any problems, just have the teacher, the substitute, pause and backtrack them as we go. Now here, we're going to see if we can divide out, but we really don't have to divide out common factors, because if we plug in the value, we'll be okay, because it's not going to cause any issues in the denominator. So it's a rational function. All we have to do is 25 minus 10 minus 15 all over 5 plus 3. 25 minus 10 is 15, minus 15 is 0. 0 over 8, which is 0. If you had factored this, get x minus 5, x plus 3, all over x plus 3, these two factors would divide out. You'd just be left with x plus 5. Excuse me, not x plus 5, sorry, x minus 5. And then direct substitution for the limit would have gotten 5 minus 5, which would get you to your 0. Now for number 8, when you have x cubed plus 12x squared minus 5x over 5x, plug in a 0, you have a problem. But if we factor out a common factor, we have an x cubed, we have an x squared, we have an x, I can factor out and say this would be the limit as x goes to 0 of x times x squared plus 12x minus 5 all over 5x. And now that x and that x divide out, so I'm left with the limit as x approaches 0 of x squared plus 12x minus 5 over 5. Plug in a 0. We get 0 plus 0 minus 5 over 5, which is negative 1. So let me zoom that out just a little bit more so we get the whole thing in there. There we go. Now for number 9, we're going to kind of do the same thing. We're going to factor out whatever we can factor out just to make our lives easier. So this would be the limit as x approaches 3 of x plus 3, x minus 3. Now we have 15. We're going to get x minus 5, x minus 3. Alright, so now we have a removable factor. That's a removable discontinuity right there. So remember, removable discontinuities gives us a hole. This gives us a vertical asymptote. So if it asks you to find a vertical asymptote, it's non-removable, so we have to do that. Now plug in the 3, so we'll get 3 plus 3 over 3 minus 5, which would be 6 over negative 2, which is negative 3. So, like I said, if you need to pause or go back, you'll have this. This will also be posted on the website, so you have access to this. So there's no excuse for not being able to get access to this. And I'll send it out as well. Now, these are fun, and these should be pretty easy, because all it is a plug in and go type of situation. Since we have the limit as x goes to 2 of f of x is equal to 3, the limit as x goes to 2 of g of x is equal to negative 5, our property says that we could just multiply them and get the answer. So this is just going to be 3 times negative 5, which is negative 15. That's your answer, negative 15. Same thing with this one. Since they're all going to the same value, we can just divide them. So this guy would be equal to negative 1 over negative 6, which is 1 over 6. So this is just, like I said, this test is going to hit the properties pretty hard, and this is going to be one of those properties that it's going to hit hard. So those are the answers. You just plug them in and go. Now for number 12, first, we have two different limits that we're trying to find. The limit is x goes to -1 of f of x from the left. So we follow it in from the left. It's going towards the value of -2. So the limit as x approaches 1 from the left of f of x, sorry, I was already looking forward to the answer, I do that a lot, is -2. Now the limit as x approaches 1 from the right of f of x, there it is, it's going towards -7. So we get -2 and -7. Now, when we're doing one-sided limits, if there's no issue here, and the issue would be we're taking a square root, we can't take square root of a negative number, but if we put 0.5 in there, we get 1.5 and 2.5. So we're not going to get any issues. And since this function is continuous on its entire domain, and 0.5 is in the domain because we're not getting a negative number in the square root, we could do direct substitution. So this guy, we do direct substitution. Now I'm going to use 0.5 is equal to 1/2. So I'll say this is equal to 1/2 plus 1 over 1/2 plus 2. So 1/2, 1 is equal to 2 over 2, and 2 is equal to 4 over 2. So I'm going to get 1/2 plus 2 over 2, 1/2 plus 4 over 2, which is equal to 3 over 2 divided by 5 over 2. Now, way back from algebra, if you had a complex fraction like this and your denominator is the same in both, your answer is the numerator divided by the numerator. But if you wanted to change that, this would be equal to the square root of 3/2 times 2 over 5. The 2's divide out, so we get 3 over 5 as our answer. And when we're doing a one-sided limit, because it ended up that point was in the domain, the one-sided limit is going to be okay to just do a direct substitution with. If we found out that it was like at an endpoint, or if it wasn't in the domain, then we'd have to analyze it a little bit further, talk about like negative 0.5001, that type of a thing. Now this guy, we need to rationalize the denominator. I know that right off the bat. Just rationalize the denominator. So we're going to get the square root h squared plus 5h plus 3 minus the square root, or plus the square root of 3 over h squared plus 5h plus 3 plus the square root of 3. So this would be equal to the limit as x goes to 0 from the right of h squared plus 5h plus 3 minus 3 all over h times, and I'm just going to do, well, no, I'll write it all, plus 5h plus 3 plus the square root of 3. Now the nice thing here, I got a crazy square root going on, but my limit is actually going to 0. So my life is going to be a little bit more, it's going to be less complicated. These two numbers, positive 3 and negative 3, they're going to subtract out. So I'm going to be left with h squared plus 5h, which is equal to h times h plus 5. So this is the limit as x goes to 0. And since I'm running out of space, I'll say it's h times h plus 5 over h times the two square roots. I'm running out of space there, so I had to do that. But just those two values are going to go into here. These two h's divide out. So I'm left with the limit as x goes to 0 from the right of x plus 5, or h plus 5 over the square root of h squared plus 5h plus 3 plus the square root of 3. Now, direct substitution is going to get you h is 0, 0 plus 5 is 5, 0 plus 0, so we'll get the square root of 3 plus the square root of 3, and this would be equal to 5 over 2 times the square root of 3. We don't have to rationalize the denominator, so that's always a nice thing. Now, are you going to have a problem like this on the test? Absolutely. I like those. Alright, find the limit using... Oh, we don't want to do that. I want to go back over here. I want to move up. Sorry if anyone's getting dizzy. Now, remember, the angle 5x has to agree with the x that's in the denominator, like x equals x here. I need this to be a 5x. The only way to have that happen, 5 over 5. And this is going to end up being an answer of 5 times the limit as x approaches 0 sine 5x over 5x. This whole thing is equal to 1, so our answer is 5. Now finally on the back, as we're going to -2, -2 would give us an asymptote, so we're looking at a limit with an answer of infinity. I have a -2, I'm coming in from the left, so I'm going to have -2.00, like 001 plus 2, which would give me a -0.00001. That negative is going to give me a negative down there and a positive up here, and since I'm going to infinity in this case, it's going to give me a negative infinity. Now here with 0, I take a cube root and then I square it. It's going to be positive, so it's going to be whatever. If I have a really small number on one side or a small number on the other side, it's still going to, whatever the cube root is, if it's negative, we'll take the cube root first. It's either negative or positive. Then we square it, and it's going to be positive. So this is going to go to 1 over a very, 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 very small number, which is infinity. Now 18, your favorite, the secants. This is going to be going to a negative pi over 2 from the left. Now remember, secant is equal to 1 over the cosine. So the cosine won't exist at pi over 2 because it's 1 over 0. So we're going to the coming in from the left. So now we have to ask ourselves, alright, well, are we going towards negative infinity or are we going towards positive infinity as this is going to happen? Now, negative pi over 2, if I just took a look at the coordinate plane, negative pi over 2 is over here. And I'm coming in from the left. So I'm coming in from the left. So let me ask you that. Is the cosine negative or is the cosine positive as I'm coming in from the left towards pi over 2? Well, remember, x is less than 0 over here, so x is negative, so my cosine is going to be negative. So this leads me to say that this is going to be a negative infinity. Because the secant, remember, is 1 over cosine. Since the cosine's negative, to the left of negative pi over 2. And negative pi over 2 just means we're going in the opposite direction. Our angle is going in the opposite direction. We get a negative infinity. Now, find all points where we have a discontinuity. We have discontinuity at x equals 4. That's the only one that I see that's we have our discontinuity. The intervals on which it's continuous, Well, where is it not continuous? It's not at x equals 6. Is there any other one? And in that case, no. 6 is the only problem. So we're going to go open interval, negative infinity to 6. And since we can't equal 6, it's open. Then we're going to go 6 to infinity, and infinity has to be open. Now for 21, the final one, if you square anything, are you going to get a positive or a negative number? That's what you want to ask yourself. This is going to give me a positive number. This is a positive number. A positive number plus a positive number is equal to a positive number. Is it ever going to equal 0? Can I get that into a negative 6 plus 6? No, I can't. So this is continuous everywhere. No matter what x I put in, I'm still going to get an answer. So this is continuous on all real numbers, so it's the open interval from negative infinity to positive infinity. Now, if you have any questions on this, now, a couple other things that weren't on here that you'll probably see. Continuity at a point. We didn't talk about that, so continuity at a point is probably something that you will see on the test. So I don't want that to be a surprise. Take a look at that problem of the day. And it might not be a piecewise function, but it might be something like that. But other than that, you'll probably get anywhere from 20 to 25 problems where you have to find limits. And remember, since everyone's sitting right next to each other, there are going to be two versions of the test. So you're not going to be able to copy off each other. And I'll have two versions of the test for 6th hour as well. Good luck. If there's questions, email me. Just remember that, oh, that's not right. Well, that would get me there. You would get a response, but this one you'll get a better response. And just remember, my wife's having surgery, so I'll be kind of busy with that, and then I have a swim meet, so it might not be very quick as I respond, but I will respond, and I will look. My last look will be at 9 p.m. So get your emails in by 9 p.m. Good luck, and if you have any questions, I'll be in a little bit early on Friday to answer them.